Hello, advanced geometry students. Mr. Donaldson here, and today we're going to start chapter 5, and we're going to do section 5.1. And so section 5.1 is called the Polygon sum theorem, and it is an extension of the triangle sum theorem. So remember, the triangle sum theorem said that if you have a triangle, all of the angles in the interior of that triangle add to 180 degrees. So suppose this is 90 and this is 50. Then we could find that this one has to be 40 because they all have to add to 180. So in any polygon, we can also determine what all the angles inside have to add up to, or the interior angles, what they must sum to. But the way we do this is we build on our knowledge of the triangle sum theorem. Just as the nature of geometry, we're going to take concepts we already know and we'll expand on them. So for the polygons below, draw all diagonals that you can from one vertex. I'll model this, but I'd like for you guys to do this on your paper as well. How many triangles are formed? Use this to figure out the formula for the sum of the measures of the interior angles of a polygon. So as you can tell, it's going to change, right? The number of angles increases. This one has 4, this one has 5, 6, 7, and you can also visually tell that the size of all the angles begin to increase. So it's not one constant value. So every triangle adds to 180. And there's a value for what the angles inside of a quadrilateral add to, a pentagon, a hexagon, a heptagon, and etc. So by following the rules, I'm going to take this vertex. It doesn't matter which one you choose. How about we choose this vertex? I'll go and highlight the vertices I'm going to use for each one. Maybe this one, maybe this one. Again, it's irrelevant. And from each vertex, I'm going to draw all diagonals that are possible. Now remember, a diagonal cannot go to the vertex itself, cannot go to the one directly to its right, or directly to its left. It must go to a non-consecutive vertex. So in this case, I could draw one diagonal. In this case, I could draw two diagonals from this vertex. In this case, I could draw 1, 2, 3 diagonals from one vertex, because I can't go to consecutive vertices. In this case, I could draw 1, 2, 3, and 4. And you guys should notice what I'm doing here. And what I've done is I've taken this entire polygon and I've divided it into nothing but triangles. 2 triangles, 3 triangles, 4 triangles, 5 triangles, etc. Now, this polygon had 4 sides. This one had 5. 1, 2, 3. This one has 6. And this one has 1, 2, 3, 4, 5, 6, 7 sides. So in this 4-sided polygon, when I drew all the diagonals from one vertex, I created 2 triangles. And in this pentagon, this 5-sided polygon, I've created 1, 2, 3 triangles. In the hexagon, I created 4 triangles. In the heptagon, I created 1, 2, 3, 4, 5 triangles. So here's the idea. The idea is that this angle plus this angle plus this angle adds to 180, and this angle plus this angle plus this angle add to 180 because they are each triangles, and the triangle sum theorem says all the angles in each triangle add to 180. So what I have here is I have 2 triangles, each one sums to 180 degrees, and 2 times 180 is 360 degrees. So what I found is that all the angles inside of a quadrilateral must add to 360 degrees. Now in this case, I cut it into 3 triangles. And if each triangle has 180 degrees of interior angles, and all of these angles inside of those triangles make up the interior angles of the pentagon, I'm simply going to do 3 times 180, which is 540 degrees. So all the angles inside of a pentagon will always add to 540 degrees. Hexagon. Hexagon I was able to divide into 4 triangles. So 4 times 180 gives me 720 degrees. And then a heptagon. A heptagon I was able to divide into 5 triangles. And 5 times 180 is 900 degrees. So the idea is that you could memorize this. You could be like, all right, triangle 180 degrees. Hopefully you already have that memorized. Quadrilateral 360. Pentagon 540. Hexagon they're going to add to, I don't know what this is. 720 degrees. And a heptagon will add to 900 degrees. But the problem with memorizing that is it doesn't stop at heptagon. What do all the angles in an octagon add up to, or a nonagon, or a decagon, and etc. Right? So because a polygon can have any number of sides, it's kind of a waste of our time to memorize what all the angles in a specific polygon add up to. So what we do, sorry about that class, it kind of glitched out on me. So rather than memorize what all the angles inside of a polygon add up to, we're just going to learn a formula that we could apply for any number-sided polygon. So let's look at the pattern here. The pattern is if you start off with only the sides, so some polygon that has n sides, some unknown number of sides, we're going to use n to represent the number of sides in our formula. Notice the pattern. I took the number of sides, I subtracted 2. That's how many triangles there were. And then I took those number of triangles and I multiplied that by 180 because that's the number of degrees, or the sum of the degrees inside of each triangle. So if there are n sides, there would be n minus 2 triangles. And then therefore, the sum of all the angles inside of that polygon would be n minus 2, the number of triangles I could create, times 180 degrees. This, my friends, is the polygon sum theorem. For any polygon, all of the angles inside will add up to the number of sides minus 2 times 180 degrees. All right? So let's write that down. The polygon sum theorem simply states the sum of the measures of the interior angles of an n-gon is n minus 2 times 180 degrees. So you simply just need to know the number of sides, subtract 2 from it, and multiply by 180. So let's talk about an example here in a second. But first, you should definitely remember in a quadrilateral to add up to 360. You'll see quadrilaterals a ton. Now again, if you forgot that, you could always do, okay, quadrilateral has 4 sides, minus 2 times 180, 2 times 180, 360 degrees. All right, the sum of the angles in a pentagon, you should definitely memorize that. You'll see pentagons a lot, 540 degrees. If you forgot that though, and no big deal, all you got to do is use the formula, 5 minus 2 times 180, which is equal to 3 times 180, which is 540 degrees. Now, suppose you wanted to find one interior angle measure. Well, let's talk about a regular pentagon just as an example, okay? And then we'll use this to kind of lead us to how you do it for some unknown amount. So suppose you have a regular pentagon. Now remember, regular means all the sides, and more importantly, all the angles are congruent. And I want to know just one of them. So first thing I got to do is be like, well, what do they all add up to? So I would do 5 minus 2 times 180, and that will be what they all add up to, but there's 5 equal angles inside of here. So I will divide it by 5. And now to take this and kind of generalize it for any number side polygon, you would simply do n minus 2 times 180 divided by the number of angles or sides that polygon has. So you would use this formula to determine what one angle measure is in any given polygon. So this first formula is for the sum, and this formula is for one interior angle. All right, let's do some examples. So find the sum of the measures of the angles in a convex decagon. All right, convex, remember, just means it doesn't cave in. We're only going to deal with convex polygons, so don't really stress concave right now. We can talk about that later if there's time. But a decagon, you guys, you must remember this, has 10 sides. So because it's sum of all the interior angles, I should have said interior angles, excuse me. It's important to be very specific. I'm going to use my formula, n minus 2 times 180. This is for the sum. I'll simply plug in. A decagon has 10 sides, and 10 minus 2 times 180 is 8 times 180, which is 1,440 degrees. So if you have a 10-sided polygon, a decagon, all of the angles inside of it would add to 1,440 degrees. Find the measure of one interior angle of regular heptagon. So remember, the formula for one interior angle, not the sum, but for one, is n minus 2 times 180. That would give you the sum, but divided by the number of angles that are there. So a heptagon has 7 sides. So we'll simply plug in and do 7 minus 2 times 180, and we would divide that by 7. And then we'll just crunch the numbers. So that's 5 times 180. Divide that by 7. And we get kind of a gross one. All right. This is a round. This one is approximate. Okay. Each angle measure is approximately 128.57 degrees. Roughly. All right. Sweet. And then there's one last example. All right. So this is probably the hardest of these types of questions. So if a regular polygon has an interior angle measure of 170 degrees, well then how many sides does it have? So I'm telling you in the problem that it's regular and has an interior angle measure. So one interior angle measure is 170 degrees. I want to know how many sides does it have? What is n? Well, in this case, I need to use the formula that would determine one interior angle measure of a regular polygon. So here's my formula. This formula gives me one interior angle measure of a regular polygon if I know the number of sides. But this time, I don't know the number of sides. Rather, I know that it's 170 degrees. So I need to do a bunch of algebra to isolate n and get it by itself. So the first thing I'm going to do to both sides is get rid of my fraction. I'll multiply both sides by n, and I'll get n minus 2 times 180 is equal to 170n. Then I will distribute. So that will be 180n minus 360 is equal to 170n. Then I will subtract 180n from both sides. And I get negative 360 is equal to negative 10n. Alright, so now divide both sides by negative 10, and I get n is equal to 36. Now listen to this question. How many sides does it have? Think about this answer. 36 sides is a great answer. But check this out. Suppose I got an answer that was negative 8. You can't have negative 8 sides. That wouldn't make any sense. Suppose you got an answer that said 23.56. You can't have a fraction of a side. So one good check with a problem like number 3 is that if it asks how many sides does it have, you better get an integer answer. And then one just last quick example that isn't on the note sheet. The problems in homework are going to look something like this. All right, suppose you have some polygon. I'm not marking it as regular or equal angular or anything. Suppose this angle is like 105 degrees, and this one is 110 degrees, and this one is 93 degrees, and this one is 113 degrees. And we want to know x. Well, the very first step is like, what do all the angles add up to? Well, this is a pentagon. So you'd use your little formula, 5 minus 2 times 180. And you say, okay, step 1, they all need to add to 540. And now from here, you just set up an equation. Be like, okay, x plus 105 plus 110 plus 93 plus 113 is equal to 540. And now we're going to solve for x. So first thing I'm going to do is combine all my like terms here. So, x plus 105 plus 110 plus 93 plus 113 is 421. So x plus 421 is equal to 540. Then we'll simply subtract 421 from both sides, and I get that x is a 119 degree angle. Booyah. So when I'm asking you to find an individual angle measure, you've got to find the sum first. All right, hopefully that makes sense. Good luck on your assignment, and we'll catch you next time.